In this video, we will look at query languages. The geometric entities in a model can have attributes. These attributes are key value pairs that are attached to geometric entities. Under the hood, such attributes are typically stored in a table structure. Each row in the table represents one geometric entity, and each column represents one attribute. In the example, the table contains 4 polygons, and each polygon has an ID and 4 additional attributes. When geometric entities have attributes, it is useful to be able to search for entities. Search tools can be found in many spatial modeling applications. Such applications usually have some kind of user interface to help users construct valid queries. These queries are more structured than the typical internet searches performed by search engine. We will do examples of 2 such applications to see how queries are formulated: Qgis and Archicad. Qgis is a GIS application in which geometric entities are stored in a relational data structure. The geospatial data can be filtered using queries. The user interface for constructing queries provides various operators to create conditional statements. These statements can be combined using logical operators. For each entity in the data set, if the composite condition is true, then it will be included. If not, it will be excluded. Archicad is a BIM application. The data structure used for such applications is not transparent. However, BIM entities also have attributes and properties, so queries are also possible. Archicad provides a user interface for finding and selecting entities in a model. A list of criteria can be specified, and in order to be selected, all the criteria must be true. For each criteria, an attribute type and operator can be selected from a list, and a required value can be specified. Both of these examples show the idea behind a query, which is specifying a set of conditions based on attribute values. When writing code, it is also possible to specify similar types of queries. Next, we will briefly look at how we can perform queries in code. When writing code, queries can be implemented using a simple loop. The search can be defined as a loop that iterates over all rows in the table. The loop body can contain various conditional statements to be able to extract the right data. In the example code, we search for polygons that have an attribute called type, with a value a. The code loops over all polygons. When it finds a polygon that meets the search criteria, it adds it to the end of a list. But all that code is quite a lot of work. It is hard to read, and it is likely to be inefficient and slow. Another option is to use a search function. Such functions may be built into the system. The example code uses a filter function to filter all polygons in the model based on a set of criteria. This reduces the amount of code, but it is still not very convenient. The code is also quite hard to read. If the scripts are going to require many queries, then a more concise solution would be desirable. Instead of using a function, another option is to have specialized constructs built into the language. These constructs can make the process of writing queries more concise and flexible. The Mobius language has a set of constructs for querying the model. In the example, we show how the Mobius code would look. The hash symbol is used to get entities. The question mark at symbol pair is used to filter entities based on a condition. We will explain these types of queries in more detail later. Languages with specialized constructs for writing queries are called query languages. Queries can easily get quite complex. For example, the query may be, get me the value of attribute A, for all the rows where attribute B is greater than 60. Next we will briefly look at the most popular query language, called Structured Query Language, or SQL. The SQL language is a query language for relational data. The advantage of performing queries with relational data is that they can be very fast. The language has different parts. Here we will focus on the query part. The query is expressed by a series of clauses, with the three most common being select, from, and where. The select clause is used to specify a list of attributes you want to extract. The from clause is used to specify the table from which you want to extract those attributes. And the where clause is used to specify a number of conditions that must be true. For the data that is shown, the query would select two polygons from the table. In Mobius, we will see that we can use expressions to query and filter entities in the model in a similar way. The syntax is not the same as SQL, but many of the concepts are similar.